When you see law of cosines, you realize that there's something familiar about part of it. This little section right here just looks a lot like the Pythagorean theorem. In fact, the Pythagorean theorem is a special case of the law of cosines. So let's look what happens when we use the law of cosines with a right triangle. So our angle A here is a right angle, a 90-degree angle, and we're trying to find side A. Obviously, I don't need to use the law of cosines to do this because it is a right triangle. I could use the Pythagorean theorem. But let's just show you what happens when we use the law of cosines. So I'm going to substitute in here as a squared, and then my b and my c. So this would be 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 90. Well, if I do cosine of 90, let's just recall a little cosine graph here. This would be cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is -1, cosine of 270 is 0, cosine of 360 is 1. So cosine of 90 is equal to 0. That's this point right here. So 2 times 3 times 4 times 0. So we have a squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times 0. So all of this just goes away, and we're left with the Pythagorean theorem. A squared is equal to 9 plus 16, which is 25, so a is equal to the square root of 25, which is 5. Okay, so we knew that was a 3, 4, 5 triangle. And when we use the law of cosines, this added part disappears when we're dealing with a 90-degree angle. So let's see what happens when that angle is not 90. So let me make this angle less than 90. So let's just call this now. We have the same length side, so we'll say this is still 3, this is still 4, this is still A and B and C. I still want to find A, but now my angle is 80 degrees. So I have A squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 80 degrees. So A is going to be equal to the square root of all of this. 3 squared plus 4 squared, 2 times 3 times 4 times cosine of 80. Now I could figure out 2 times 3 times 4 and write that in there, but just to show you, I can just type it all in my calculator like this. And when I put it in my calculator, I want you to think through. Cosine of 80 is a value that's in quadrant 1. If you look at the little graph here, cosine of 80 has to be in between 0 and 1 because cosine of 0 is 1, cosine of 90 is 0. So cosine of 80 has to be in between 0 and 1, but it's going to be a positive number. So I'm subtracting a quantity then from 3 squared plus 4 squared, so I'm going to end up with, as you would expect, A is going to be a little less than 5 because now it's opposite an angle that's less than 90. So if I go to this on my calculator, you'll see right here that this is the first line, it's 4.56. Okay, so it's a little bit less than 5. Now what happens when we do an angle that's slightly bigger than 90, or any bigger than 90? It doesn't have to be just slightly bigger. So this is still 3, this is still 4, this is still A and B and C. I still want to find A, but I'm going to make this 100 degrees now. So A squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 100. A then would be the square root of all of this, which is going to be, you would guess, bigger than 5. Okay, because when it was at 90 degrees it was small, it was 5. When it was less than 90 it was smaller than 5, so this is going to be bigger than 5. And if you do this on the calculator, you will find out, yes, this is a number bigger than 5. What I want to point out though is, why is it bigger than 5? So if you look at cosine of 100, recall that cosine of 100 is in quadrant 2. This is 5.4, so I'll write that down. Just 5.4. So cosine of 100 degrees would be right here. What do we know about cosine in quadrant 2? Cosine in quadrant 2 is negative. So negative 2 times 3 times 4 times a negative number, I'm subtracting a negative number, which really means I'm adding something. So that's why this part of the formula becomes a positive number when cosine is greater than 90. So then a becomes bigger than what it would be if it was just 3 squared plus 4 squared. So I just wanted you to see how the law of cosines relates to the the Pythagorean theorem. When a is 90, it just equals the Pythagorean theorem. If a is less than 90, then I'm subtracting something from what that would have been if the angle had been 90. And if cosine is, this angle is greater than 90, then I'd be adding something and making this side a little bigger.